Let's go ahead and get started with Exam 2 Review Part 1. When it says factor by grouping, what you're going to do is you're going to group two terms together and then another two terms together, and then you're going to factor out common factors and group again. Now, when you notice that your middle operator is a minus instead of a plus, you want to be careful. And the way you be careful is you change that subtraction to addition and change the sign there to a negative. So once we've done that and we've got this middle operator to be positive, we're ready to group, and we can just group off two sets of terms like that, and then find common factors, which in the first case are going to be 2y leaving 3x plus 4. And in the second, you expect a 3x plus 4 also. So you might even think about that when you're trying to figure out what to pull out. But we can pull out a negative 7, and we're left with 3x plus 4, because the negative 7 takes care of the negative signs inside. So now we can treat our 3x plus 4 as a common factor, and that leaves 2y minus 7, and that's the answer. Okay, when you see a polynomial like this, you see some big numbers, and you can use your techniques that you've learned so far to do this without having had to memorize something, but it'll be a lot harder than if you notice this is a perfect square trinomial and this is a perfect square trinomial. So let's rewrite that as 6 squared y squared and 5 squared, and wouldn't it be nice if this just factored to 6y minus 5 squared? Well, it will factor that way if this term is 2 times 6y times 5. Is it? It's 2 times 6 is 12, 12 times 5 is 60, and so it is, so that checks. So basically the equation is, if you have a perfect square minus 2ab plus another perfect square, that's going to factor to a minus b squared. The other formula that's similar is if it's all pluses, that's going to factor to a plus b squared. So I strongly urge you to recognize those formulas, memorize them, and be able to recognize perfect squares when you see them. Okay, here we're to factor a trinomial, and we start out by saying, do we have any common factors? And the answer is no. And then, is this a perfect square trinomial? No, because 6 isn't a perfect square. So is there a coefficient in front of the a squared term? And yes, there is. There's a 6. So we're going to have to factor this using grouping. And in order to do that, we need to find two factors whose products are 6 times negative 3, which gives us negative 18. And these factors have to add to give us negative 17. So when they're close like that, you know it's going to be negative 18 and positive 1. When they add to negative 17. Okay, so for grouping, when you rewrite this, you bring down the first term, and then you write the second term using your new factors, and then you bring down the last term. Okay, so notice that these two factors here, which we got from our work over here, add to equal this. And then this one is simply that, and this is simply that. Okay, now that you have 4 terms there, you check to see if that middle operator is a positive, if it's a plus, and it is in this case. So then all we have to do is group, and then pull common factors. So in the first case we have 3a, or actually we have 6a, so let me rewrite that. we have 6a, and that leaves a minus 3b, plus 1 times a, or we have b actually, b times a minus 3b. And so that gives us a minus 3b times 6a plus b. Okay, so we think that's our answer. Let's check our work by foiling. We FOIL the first term. A times 6a gives us 6a squared. Then we FOIL the outer terms. A times b gives us plus ab. Then we FOIL the inner terms. Negative 3b times 6a gives us minus 18ab. And then we FOIL the last terms. Negative 3b times b gives us minus 3b squared. And now we combine our like terms, which are in the middle, and we get 6a squared minus 17ab minus 3b squared. And we compare this answer to what we started with, and it's exactly the same, so that means that this is the correct factorization. When you see a problem that has a huge number in front of the lead term, like 81z squared, and then big numbers all over, the first thing you want to ask yourself is, do I see perfect squares anywhere? And so 81 is a perfect square, 9 squared. 121 is 11 squared. So you need to know that. You need to memorize at least up to 15 squared. So now that we know that the first and last terms are perfect squares, we need to run a test. We need to know if the middle 198 is 2 times the first term, 9, the base, times the last term's base, 11. So 2 times 9 times 11. And so 9 times 11 is 99 times 2 is 198. And you also have to make sure the z and the b are in the middle. Then that checks. So we know now that this is a perfect square trinomial. That means that we can use the formula a squared minus, in this case, 2ab plus b squared equals a minus b squared. So that would mean we would have a would be 9 and b would be 11. So our answer is going to be 9z squared, 9z minus 11b, all of that squared. So once you identify that it's a perfect square trinomial, then you find the base of the first, which is 9z actually. So 9 squared z squared gives you 81z squared, and the base of the last, which is 11 squared b squared. And make sure the middle term is 2 times the base of the first times the base of the last, and if it is, then you simply write down the base of the first, and then if this up here is a minus, you put a minus, and then the base of the last. If it had been a plus, you would put a plus there. Okay, here we have a trinomial with big numbers, and there are no perfect squares, no common factors, so we have to do the big numbers. So we're going to use grouping because there's a coefficient that is not 1 in front of the t squared term. So we need two numbers that multiply to give us 6 times negative 77 and add to give us 19. Now, I didn't break this down anymore because I want to find those numbers, and I know if I just multiply 6 and 77 I'll get a pretty big number. But I know that we have 6 and we have 77, which is 7 times 11, and it's going to be a negative. So I need some combination of factors that are going to add to 19, or actually that their difference will be 19. So if I have 6 times 7, that's going to be 42, and the difference of 42 and 11 is not 19. So 42 and negative 11 won't work. They'll give us 31. Okay, so let me break up that 6, and I'm going to get 2 times 3 times 7 times 11. What if I take 3 and 11 and make 33, and what's left is 2 and 7 to make negative 14. So if I try 33 and negative 14, I do get 19. So I was able to use some factoring tricks to give myself to find the 33 and the negative 14. So I'm going to clean up the board a little. Okay, so now I can rewrite keeping my first term the same, 6t squared, and then I have negative 33 or positive 33 and negative 14. Remember, I want my middle operator to be a plus, so I'm going to write the minus 14 first. Minus 14tu plus 33tu, and then I'll finish up with bringing down my 77u squared. So now I can go ahead and group. So in my first case, I can pull out a 2t. So I will do that, 2t, and I'm left with 3t minus 7u. So I hope I get a 3t minus 7u in my second term. And I see I can pull out an 11u. And what do I have left? 3t minus 7u, just like I want. So now I can treat 3t minus 7u as the greatest common factor, and what's left is 2t plus 11u. And that's the result. In this problem, we're to factor out the greatest common factor. And first, let's look at the exponents. We have f's in every term, so we know we're going to factor out some f, an f to some degree. We look at the smallest exponent, and that is f squared. 2 is the smallest exponent. So that means we can factor out an f squared from all of these terms. So your job is write f squared, and then you're going to divide all of these terms by f squared to see what's left. But that's not all we can take out. 7 goes into 56 8 times, so we can take out a 7 as well. So now we need to divide all of these by 7f squared. And in the first term, what we're left with is f squared, because the 7's cancel, and when you divide by exponents that have the same base, you merely subtract the exponents. In the second case, we have 8f, and in the third case, we have 8. And so that's it. We have factored out the greatest common factor, which is 7f squared, leaving us with f squared minus 8f plus 8. Okay, what I notice here is that this too is the difference of squares. It's a little bit tricky because x to the fourth is x squared, and 25 squared is 625. So my squares, a is going to be x squared and b is going to be 5, so that if I have a difference of squares, my formula is a plus b, a minus b. So in this case, I have x squared minus 25 squared. So that's going to be x squared plus 25 and x squared minus 25. And if I look at my x squared plus 25 term, I see I have a sum of squares, and you can't factor that any further. That's prime. But here I have a difference of squares, so I can factor this. This is x squared minus 5 squared. So that rewrites, I can keep my x squared plus 25, but my x squared, whoops, let me clean that up a little. My x squared minus 25 factors using that same formula to x plus 5, x minus 5, and that's the end result. Now you can go on to part 2 of the exam review.